Hello, everybody. This is Sowmya, Myneni. I'm here today to present to you how to build a threat detection mitigation framework using HPCC and Azure at the core. So I have been working as senior security engineer at LexisNexis Risk Solutions, and it has been great. And I got to develop some technology models, innovation, and security controls as well. So I'm glad I got this opportunity to present this to you. So today I'll be going through these, basically the details on the core, the framework, what are the elements of the flow, and how we can build the data lake house using the elements that we have proposed here. So at the core, we are using HPCC and Azure. HPCC, why? Why do we want to use HPCC? Because the data, particularly in case of cybersecurity, the data is humongous. There are huge volumes of data coming in, not just the information about the scans that the tools are scanning the reports, right, every day. And there are tools that scan the applications. And there is network traffic that is collected. And there are tools that are collected by the host detection systems, host detection systems. So all these data is humongous. And considering that, in fact, it's humongous, even like every minute of this data, it holds a large volume of data set, which we need to have it go through the HPCC or some big analytics data model. But we choose HPCC because it's open source and it comes with the flexibility because it's in-house and we have cost-effective solution. Furthermore, it supports machine learning analysis, and we can use the models that we would like to, based on the research performed in cybersecurity, to better our threat detection mitigation models. And why Azure? Because we are able to enforce these standards and policies to make sure security is applied as per to the requirements of the organization. And also, we would like to have a centralized data store, wherein the data, raw data, and the process data are all maintained, while also providing a facility wherein people can come in and pull the data that they need to further their analysis. And we can also achieve security automation when using Azure components, as you can see in the later slides. This combination, we believe, has made our solution work to the way that we need. So the framework that we have here is like, this is like outline that I am showing you here. So on the left, you see there's this Azure, everything is on Azure, except there is an express route connection at the top, which is a connector between the Azure cloud and the on-prem data sources, or even the internet, as I say. We have other data sources that are internet. So on-prem, we use express route connection to connect to these data sources and pull the data. So these data sources could be any tool. They could be Cloudflare, that if you are using a Cloudflare tool to for DDoS protection, or if it's say if it's like a back tool like Imperva or Radware, you could have that as a data source. You can pull the data from them through the API calls. So on the left, you have here, you see, is a function app that is retrieving the data from these data sources. We have actually a set of functions that are running using that app, function app server, and they are triggered based on time. And we suggest using a Azure key vault, where you can store the secrets needed to make those API calls. Now from this function app, the data that is pulled by this function app is going to be stored into this Azure file storage. So Azure storage account, right? We have tables, files, blobs, different types of storage types, right? So you could use file. We suggest using file storage here, file share maybe. Because it's for now you can use file storage or even blob because it facilitates the transformation or the further steps, as you can see in the later slides. More details about this. Now the file storage, as the files are uploaded into the file storage, Azure storage account, we have this logic app that gets triggered. that is triggered to transport this data from the Azure storage account to the HPCC storage account. Now the middle central rectangular box is all about what is happening in the HPCC system. So there in this HPCC that we built was on AKS and is running on Azure AKS, Azure Community Service. And we have Azure storage account used as a landing zone for this. Now this logic app on the left box is pulling the centralized data storage account where the raw data is held and transporting it into the HPCC data with storage account, HPCC storage account. Now this file is then run through sanitization process and a feature extraction process, and then normalized. The data is normalized and standardized. And then the exported CSV format is also saved, retained for further usage by other components. But the main goal of using this HPCC is also here comes not just processing and normalizing the huge volumes of data, but also to run through these analysis. Analysis using machine learning and rule-based analysis. We would like to run through that on HPC systems. And now this data output of the analysis, output with output of CSV is stored in the Azure storage account, back again in the Azure storage account. We could store it here again in the Azure file shared format, or you could use its table storage. Now, if you are using a table storage, you can display the results, easily access the data using Power BI and directly pulling the data from the tables. If it is a file storage, you can also use SQL Server to build the files, do further processing if you want to, and then use Power BI. Sorry. So, as I go to the deeper into the details of the flow, this could be a typical workflow, the framework. So we begin with data collection, and then the data collected needs to be transported to the place where it needs to be transformed. And transformed data needs to be transported again to data analysis, and then analyzed data needs to be transported again to the data storage account. So why we need to have so many times the data transportation coming in? Because we want to segregate the elements of the flow. We do not want them to be depending on each other. Rather, we depend on the data transformation to make the data available as needed. The data transformation will be triggered independently within the HPCC storage account. That would be the trigger for it. Here there are other automations that we can set up, and data collection has a set of automation elements. Data has again another set of automation. So combining all these automations together, we build the security framework. So going into each of these details, each of these elements. So first we begin with the data collection. In the data collection, we have this Azure function app, which, as I mentioned earlier, is a set of functions. Say each function could pull data from a different data source. A set of scripts triggered independently to collect the data from these multiple sources. These are like a collection of scripts. This could be Python, this could be C#, this could be Node.js, anything that you would prefer to use to pull the data. Now, once this data is collected, you save them in the storage account. As I mentioned earlier, you could save it in the blob storage. You could also save it in the file share. So the benefits of file share is, when using file share, the landing zone is actually in the HPCC is a file share. So transferring from one file share to another is easier, or you could also further proceed into mounting this storage account as a file share too, as a file share for the HPCC storage account. So that is another perspective, but we can simplify things based on our need. You could use a blob storage account, or you could use a table here, but because most of the times the API calls you make give the raw data often, and you further want to process it, transform it. So this raw data is usually a JSON structured data, or maybe an XML data. So this kind of structured data is better to be saved in the file storage form or blob rather than tables. So once you have this step done, the raw data is collected and saved. You then have this Azure Key Vault, wherein the secrets are stored to make these, like for instance, the API key. API user, API key, whatever is needed to make these API calls. You can use the Azure Key Vault to save these secrets. And then there are security tools, and these are the security tools. This is the part, securities. All these components are part of this data collection flow element. So the data generated by these security tools actually serves as the data sources for building this lakehouse. Not just these security tools, even you can have this network data collected. Even not just what I mean is you don't need to only use the Cloudflare or Imperva or Adware or any back tools or maybe Dependabot or whatever alerts. You can further pull the data, say VPC flow logs from AWS, or depending upon that, you can perform the analysis as needed. Maybe not VPC flow logs because the source is different and the data is so huge, you might want to process the data as there itself, as one of my colleagues says. But there are other ways that you can, other data sources, not just the security tools like the network traffic, maybe the data collected the SIM. You can also use that as the data source. And now the data is collected, right? Now we need to transport it to the place where it needs to be transformed, where it needs to be analyzed. So for that, we have used logic apps, or you can also use function app. But logic apps are simpler in this case because we want to trigger this transportation multiple times, as you saw in the elements of the flow slide. So these logic apps, it can be used to transport the raw data to the HPCC landing zone, and then once the transformed data from the data has been transformed from at the HPCC, just pick it up again and then transfer it to the storage account, the centralized data storage account. And then you might also need to run analysis. And then once the analysis is done, you need to transfer that data as well to the centralized data store. Now, the Azure storage accounts, the component, another component in the data transportation is this Azure storage accounts. These are the centralized, there is a centralized storage account, as I mentioned, that will hold the raw, processed, and analyzed data. And then there is a HPCC storage account that serves as the landing zone for the HPCC. The files that are uploaded into this landing zone gets processed, sprayed, and then transformed to ECL. And then uploaded, and then they can be transferred as well. So what happens in the transformation? So this transformation, as I mentioned earlier, is performed in HPCC. And you can use HPCC running on AKS, a very light model. You can just deploy the HPCC to meet your needs. By meet your needs, what I mean is the storage that you need to. There are some requirements on the minimum size for this storage account that HPCC needs. So like the dry file share services, some file shares need to be, basically some requirements need to be met, right? So you just can meet those requirements, build a simple AKS. Maybe you can just use a VM scale set with 2 instances for for the default node, and 1 per HPCC node or something, 2 per HPCC node and 1 per default as needed. And then you can set the scaling to be on demand with min and max again. So now with that setup done, and then making sure that encryption is turned on for this AKS with the encryption at rest, and then making sure that you have HPCC through while deploying the Helm chart. Sorry, I meant HTTP. Making sure you have HTTPS enabled while deploying through the Helm chart. You can have these security requirements met as well. And then coming to the sanitization part, now the data is collected from different sources, different data sources. Each of them has different format. And sometimes it's, even though it's JSON structured, some of the JSON structure might have all the fields, some do not. Some tools might not be returning all the fields. In some, they have more fields than the other. And then there could be invalid characters. There could be characters not that can stop your processing using certain scripts or certain analysis methods. So you have to make sure that you sanitize this incoming data, removing all those unwanted formats or unwanted data types. And then once the sanitization done, you make sure you extract the features that are needed. There are often certain features, particularly in cybersecurity. You collect, say, for instance, you are collecting this network dump. This network dump, if you convert them into the features, there are so many features that are just noise. You have to make sure you have to carefully analyze what are the features that are causing the noise and are they giving any importance to this, to the information that you are trying to gather. So remove that noise and extract the features, and then perform normalization on them to make sure not only that all the sources, all the multiple sources are following the same format on features that are common. You also have to make sure that the normalization performed on based on the category of the data. So once this normalization is indeed an important step for effective analysis. And then finally, using ECL, you can transform this data into CSV files with features that are giving value to the information that you want to gather. So once this transformation is done, comes a major step, which is the data analysis step. Why we had to do data analysis? As I mentioned earlier, cybersecurity is huge. And every minute you see a lot of data coming in through. For instance, if I talk about one department in the organization, you will have huge volumes of data just per minute of network traffic. Now you need to not only often analyze what is happening in the network, what is happening in a particular system. This system data could be collected through the HIDS, host intrusion detection system, maybe. But whatever it is, you not only need to observe this live data. Sometimes you also need to, not sometimes, it actually need even the data that is static, such as that's not dynamically flowing in every minute, that is not exponentially with every minute rate increasing every minute. But there is data such as vulnerabilities information on the vulnerabilities of an application that has been scanned. Maybe the scan has been set periodically and have this information be retrieved. So there are different volumes of data. But then why are doing analysis is eventually to detect the threat early and to mitigate the progression of an attacker further. So the another side of this coin is to also assess the risk. For instance, you have a product that has been scanned recently, say by two scan tools. One could be scanning the source code, maybe Sonar 2, and one could be scanning the application itself. Now you want to understand the risk of this product, so that when you are coming to a decision of whether to deploy, when you have another release coming up for this product, do you need to deploy immediately to resolve that risk, reduce that risk of the product? Maybe the current risk of the product is high because there has been a vulnerability that has been reported that this application is vulnerable as well. But there is also a source code vulnerability identified by Sonar Cube-SIG. Now you want to maybe deploy an update of this application because the risk of product is high. Now, how do you know that a product risk is high unless you have all this information in one place and get to know, look into the product at the vulnerability level, at the risk level? So this is where the analysis is needed. You need to be able to assess the risk to determine if you need to deploy a product as soon as possible, or you need to deploy a product in a particular location or in a different environment, or increase the security of the product to make sure the product is not vulnerable anymore. What are the steps to be taken? What is the risk? And it all starts with this risk assessment process. When you assess the risk of a product, that's where you determine how to improve the security of that product. What are the next steps? And also, as I mentioned, the first side of the coin earlier I mentioned was the threat detection and mitigation. Now, without a proper analysis, you will not be able to find the presence of an attacker. You observe all these logs, amongst logs, your feature extraction is incorrect. Or if you are looking at too much noise, you do not have the noise removed. There is often noise, right? The network traffic dump. And sometimes the attackers might just try to create the noise. They might try to deviate the security team to just creating noise somewhere, trying to penetrate into the system. Though they are not really penetrating, they might be pretending as penetrating. So that creates a noise. Now, how do you determine what is noise and what is not? It is this effective analysis. Okay, there is an attacker that is moving across the organization, but there is also an attacker that is in a particular system. Now, when often what happens is these two attacks are thought as part of one attack. But no, it could be two attackers, or it could be the same attacker trying to deviate the security team to look into a different place rather than the actual place. So how do you identify such deviations? How do you remove that noise is crucial in case of threat detection mitigation. Now, correlating these known vulnerabilities with network traffic is another way to detect these malicious activities to help narrow down what are the malicious activities that are high priority to be looked at. Another is to perform a causation analysis, just as in the scenario that I mentioned. There could be an attacker working somewhere, and there could be another attack happening somewhere. But what happens is you have to determine what is the trigger, what causes this detection to happen. There is a point at which you detect some malicious activity, right? How do you think that was detected? Maybe the attacker jumped from here, or what are the causes that made this happen? And then causation analysis makes a big difference in identifying the attacker's path, because you would know where the attacker is headed when you perform this in-depth analysis. Now, how can you perform the data analysis? I mentioned what is the need? Why do you need to perform data analysis? But how can you perform the data analysis? There are many ways. In particular, cybersecurity, I have found that however simple it is, the rule-based analysis still makes a huge difference. And machine learning-based analysis, as you have been hearing, they do really make a huge difference, particularly in case of cybersecurity data, considering the volume of the data that needs to be analyzed. As I mentioned earlier, and actually from the beginning of this presentation, I have been emphasizing how big the cybersecurity data is. And for particularly this reason, the machine learning based analysis is going to make a huge difference. Every minute, the data is in terabytes or petabytes. The data that needs to be analyzed in time is increasing, all right? So there needs to be a time-sensitive analysis requirement. So for this, we need to employ machine learning-based analysis. And while we do employ machine learning-based analysis, we still need to apply the rule-based analysis as well, because they are simple and they are removing unwanted noise because of the rules that we define. Because we, as security team, would know the information about what is important, what could have some expert analysis. We know, right? We can define the rules that are important that can be ruled off fast. In case of underlying threat that is increasing every day, this rule-based analysis helps to determine or reduce the efforts needed, or that reduce the time needed to detect the threat while used with machine learning. So together, they both need to be used together, is what I suggest. So another goal through this framework that we would like to achieve is furthering security automation. So what are the current level of security automation we have? We use security tools to scan repositories. We fetch vulnerable data by scanning applications. We have systems that report alerts when there is a vulnerability in the repository and that has been detected by another tool. There are so many tools, like there are certain, there is a level of automation that we already are employing. Almost every organization is now employing, including any startups in small scale, because of the importance of the security, because everything now is all about data. And every company is having data and it needs to be protected. So we do all employ certain level of security automation. But what we need to further is we need to advance the data retrievals from the security tools. Many organizations have security tools deployed, numerous security tools deployed. And what is being done with the data that is retrieved from the security tools? Often there is a manual review of this security tool data and then identifying, okay, is this vulnerability fixed or not? Okay, fixed, good. If not fixed, okay, let's follow up and then fix it. Maybe most of the times this is what is happening. But a vulnerability that fixed in time reduces the risk of the product. In other words, if you have vulnerability detected in your code, say, how can you identify it is not the same vulnerability that has not been reported 3 months ago? Maybe that has come repeated again. So this information is not easily retrievable because you are not probably looking into that further back. So retrievals, automating these data retrievals and going through an analysis to understand why there are these products, why the product has these vulnerabilities. Are any of these vulnerabilities repeating? What is the risk of this vulnerability? And eventually, what is the risk of this product as a whole? Not just the repository. An application can have multiple APIs, can have multiple services running or scripts being used, or even applications, websites that they can be using. And so how do you assess the risk of product? By retrieving the information of the security tool that could be scanning the application, tool that is scanning the repository, tool that is scanning the that is reviewing the that is looking at the scripts. So collection of all this information from the security tools that are retrieving all this information and automating this collection is where we can start advancing, is how you can start advancing the security automation. Using the data and automating the usage of that security tools output is one step, does one step further your security automation. And then automating the transformation of this collected data to derive information, transformation of this data, right? We are getting raw data, but we can derive an information, as I mentioned earlier, with the use case where you collect information from the source code, you collect information, you collect data from the source code analysis tool, you collect data from the SAS tool, and then you collect data from script analysis tool, and then combine all this this data to derive some information, valuable information that will give you an idea on what is the risk of that product. Now we further need to automate the analysis of the data retrieved periodically from these sources. So we do data retrievals, we do transformation, but we do need to analyze the data as well. And this data analysis is often not automated. In many cases, the data analysis is not a step that companies have stepped into yet. And including the data retrievals or even the collection from trying to derive information. These are all steps I have not seen much in usage. But these all steps could further the advancement of the security automation that your organization already has. And then another level of advancement is the analysis performed through context and causation. As I mentioned, let's say, for instance, there is a network traffic coming in. Say there has been an established foothold that occurred. And that established foothold happened, like say, sometime in the morning. But if you see often, of course, the attackers change their patterns. But sometimes, or most of the times, you see the when such an established foothold happens, like established foothold means compromising machine. Say, for instance, someone has compromised your laptop. Now, what happens is such an attacker, usually advanced attackers are the ones that are capable of entering to an organization network only if because the organization is, as I mentioned, has minimum level of security these days. Let's assume that it has minimal level of security, and so it needs to need a sophisticated or like advanced attacker who is trying to compromise your laptop, and then he compromises the laptop, but then he has to keep a shell open to make sure he can continue coming into your compromised laptop. So now, when such shell is open and then communication happens to a command and control center where the attacker is actually residing, there is this communication back and forth since the time the attacker has jumped on the system. So this is where the context comes in. You saw some activity coming into the system and you saw some activity going back to a particular system. Is that it carries a context. That means it has some, you have to use the contextual analysis to identify such patterns, because the attackers are hidden within those patterns. And contextual analysis, analyzing with the time, and helps you to determine the presence of the attacker. Not just this, another kind of context would be, say, we all every day, this particular employee signs off at 2, and sometimes 2:30, sometimes 3 p.m. maybe. Say, and then one day this employee has stayed maybe until in the evening 5 p.m. or maybe he just signed off regularly, say. And then, but you see that unusually this particular employee has signed in again in the night. This is an anomalous behavior, right? Because the context here is this employee has never been seen at the time. But why you see the sign in now at this time? This is an anomalous behavior. Identifying this context analysis, you can use some rules, but rule-based analysis here. But the problem with rule-based analysis here is you cannot really define rules around human behavior. He might have signed off early. That's why he might be signing in again in the night. That could be a reason. So defining rule-based analysis here, performing completely relying on rule-based analysis, is not going to give us any proper information. So why the attacker has signed? Why the employee has signed in the night? Okay, if the employee signed, maybe it is normal. But what if the employee is acting unusual, like accessing tools or web pages that the employee is not usually used to, trying to go through file system that the employee has access to, trying to retrieve. Is there any unusual activity? This all form the context. So you need to have a contextual analysis done as well. And this could really further the security automation that you are having, and automating this type of contextual analysis is going to up your game. And then comes the causation analysis. And causation, like what has caused a change in the state of the system, is what helps you determine the attacker's path. So attacker is moving from one system to another. Okay, there is at one point we saw that the system has turned off unexpectedly. And then we saw a neighbor system, or we saw a system that is connected to this particular system have unusual activity. So what causes? Causation analysis can help to determine the attacker's path, and in fact help you detect the underlying threat very early. And then last but not least is what we encourage you to do is automation of safe mitigation procedure. Say, for instance, you have been receiving unusual activity on a particular port, and you don't need that port to be active. You can just make sure you can review what is the usual activity on the port and determine if it is safe to turn it off, and then you turn off have the safe mitigation procedure done to close the port. It could be an instance in Azure, or it could be an instance in AWS. You can also have safe mitigation procedure there. Say, for instance, somebody launched an instance and have all the ports open, and you saw an anomalous activity coming to the instance or the VM, and then you can just isolate, have a automation built in, isolate the VM or the instance, put it in a different security group wherein you do not have the traffic coming in no longer, and keep it there to observe, to look at the data if there was really an attack or not. These mitigation procedures based on the criticality of the infrastructure that you are making changes to, automating these would level up your security as well, and helps you automate this threat detection, achieve the automated threat mitigation. So where in all this HPCC Azure comes here is automate to further the security automation, automating data retrievals. Of course, we are doing it through Azure, but the transformation happens in the ECL because of the huge volumes of data. We are using ECL where HPCC comes in, and we are using HPCC storage account as a landing zone to transform to use the landing zone to transform the files from, and then automating the analysis of the data again with HPCC, particularly because you can have machine learning analysis done as well there. And the safe mitigation procedures are somewhere in within the security controls you have to be performing on the organization with the organization requirements, security requirements met. I hope I was able to showcase how you could level up your security using HPCC and Azure by building a simple model wherein you can collect the data and perform the analysis on the data, and how such framework would be. I would like to hear any comments or feedback from you guys. Thank you very much.